Iranian Navy Commander Shahram Irani recently issued a specific warning regarding a newly deployed underwater weapon. He claimed the device is already stationed in close proximity to enemy forces, suggesting its presence alone could cause his adversaries heart attacks. This chart compares the Hoot to standard naval hardware. While typical torpedoes move between 60 and 100 kilometers per hour, the Hoot exceeds 360 kilometers per hour, effectively traveling 4 times faster than anything else in the water. This weapon operates like an underwater bullet, carrying a 200-kilogram explosive warhead designed to punch through the heavy steel of a warship's hull. On paper, this velocity and explosive mass create a weapon capable of striking a target before a crew can even register an incoming threat, earning it a reputation as a potential carrier killer. This diagram illustrates the primary challenge for underwater travel. Water is roughly 800 times denser than air, creating massive friction and drag as an object moves forward. The Hoot overcomes this through supercavitation. Instead of pushing through the liquid, the nose of the torpedo vaporizes the water, creating a continuous gas bubble that completely surrounds the projectile. Once the bubble forms, the torpedo is no longer in contact with the water. It is essentially flying through an underwater air tunnel where resistance is dramatically lower. By bypassing the standard constraints of hydrodynamics, the Hoot behaves more like an atmospheric rocket than a traditional submarine weapon. Generating a gas bubble thick enough to shield a torpedo requires a massive constant expenditure of energy, which creates a significant engineering hurdle. This map shows the resulting compromise. Because it burns fuel so aggressively to maintain its speed, the Hoot has a maximum range of only 15 kilometers, roughly half the distance of standard torpedoes. This 15-kilometer limit means an Iranian ship or submarine must close the distance and enter point-blank range before it can even attempt a launch. In naval warfare, a high-speed strike is only effective if the launching vessel can survive long enough to get within range of the target. Those targets are rarely vulnerable. The Hoot is primarily aimed at U.S. aircraft carriers, like the USS Abraham Lincoln, which are some of the most heavily protected objects on Earth. These carriers possess massive buoyancy and multi-layered hull protection designed to absorb underwater explosions. Furthermore, U.S. naval doctrine ensures a carrier never sails in isolation. It is always the center of a strike group, a massive armada of destroyers, submarines, and aircraft providing a 360-degree defense. This detection network makes it nearly impossible for an Iranian vessel to slip into the 15-kilometer firing zone without being spotted and engaged. In the open ocean, the Hoot's short range turns an attempted strike into a suicide mission against an alert and heavily armed defense. Despite these tactical flaws, naval planners still view the Hoot as a major strategic threat. This map of the Strait of Hormuz explains why. Its extremely narrow shipping lanes must be used to enter or exit the Persian Gulf. When the Hoot's 15-kilometer range is mapped against these lanes, its limitation disappears. The weapon's reach entirely covers the navigable waters. In these confined waters, a carrier strike group cannot use its distance as a defense. The geography forces the fleet to sail directly into the Hoot's lethal engagement zone. Iran can deploy these torpedoes from swarms of fast attack craft operating close to their coastline, making them difficult to target before firing. The Hoot weaponizes the specific geography of the strait, serving as a high-speed area denial tool that ensures multi-billion-dollar fleets must maintain a significant distance from Iran's most sensitive waters.